m1 is equal to m2. Now rho dash is equal to m plus m gives rise to 2m, and m, if you place m and m here, m into 1 upon rho 1 plus 1 upon rho 2. Here m and m will become cancelled. So 1 upon rho 1 plus 1 upon rho 2 gives rise to rho 1 plus rho 2 upon rho 1 rho 2. Rho dash is equal to 2 upon rho 1 plus rho 2 upon rho 1 rho 2. So if rho 1 rho 2 comes upside, 2 rho 1 rho 2 upon rho 1 plus rho 2. Okay students, we have discussed the cases and the relative density and the cases in the density of the fluid. Now we are going to discuss about Pascal's law. Okay students. Now we are going to discuss about Pascal's law. Now Pascal's law states that a fluid at rest having the pressures same, that means if the fluid is rest, now the pressures will become equal as rho 1 P1 is equal to P2. Now we know that formula for pressure, that is F1 upon A1 is equal to F2 upon A2. Now if F force is equal to constant, if F is equal to constant, then pressure is inversely proportional to area. Pressure is inversely proportional to the area. Okay students, now we have discussed Pascal's law and we have an application. It is hydraulic lift. Hydraulic lift. Now the diagram of hydraulic lift will be like this. Okay students. Okay, now here the area is A1 and here the area is A2 and the force is F1 and the force is F2. Now as we have discussed here, if pressure is constant, here pressure will become equal. If pressure is constant, then force is directly proportional to area. So here A2 is much greater than A1. Now the force F2 is greater than F1. transmit to A to area, and the force will become higher. Now, it is used in car washing centers. Okay. Okay, students, we have discussed about Pascal's law. Now, we are going to discuss the Archimedes principle. Archimedes principle. Yeah. Archimedes principle. It is the principle that gives the reasons for the buoyant force. It is the principle that gives the reason for buoyant force. Okay, now we will take a diagram. We will draw a diagram. The diagram, and it has a liquid. If we dip a cube, first of all, a cube. There is a cube having the volume V. It is having the volume V. Now, buoyant force. Buoyant force is the volume, the force exerted by the substance is equal to the density of the liquid and the volume occupied by the substance, that is dispersed into acceleration due to gravity. Due to this, the mg will occur. Due to this, the weight will increase. Now, as we know that force is equal to mg, and the mass will become equal to density into volume into acceleration due to gravity. Here density is for liquid, that is rho L, and volume is for solid, and acceleration due to gravity. So easy. Now there is a trick. For force is equal to mg, and mass gives rise to density into volume. Okay. Now density is for the liquid in which we dip the substance, and the V is the volume occupied by the substance in the liquid, and G is the acceleration due to gravity. Now we want to find the weight changed if we change the density of the liquid, density of the substance, and volume. Okay, we will write a formula. W apparent is equal to W actual into 1 minus rho L upon rho S. Now the W apparent gives the final weight, and W actual gives the initial weight, and here rho L gives rise to initial density, and rho S gives the initial density of the substance. Now we have three cases. First case is if rho L is less than rho S. Rho L is less than rho s. Now the body will float partially. Float partially. Now the diagram will look like this. It is the liquid and the body will be like this. Now there is second condition in which rho L is equal to rho S. Sorry student, did know. Parents, rho L is equal to rho S. Rho L is equal to rho S. Now the body will submerge. Submerge. And the diagram for submersion is submerge. Okay. Now third case is rho L is greater than rho S. In this, now the weight, now the body will sinks. Due to the high weight. Okay students, we have completed successfully Archimedes Principle. Now there are some points regarding the fluids at rest. Okay students. Okay, now we are going to discuss about manometer. Manometer is used to find the pressure. Find the atmospheric pressure. Now the diagram will look like this, in which we dip sense and heat with the vacuum. P vacuum is equal to 0 and here the pressure P, that is 1 and it is 2. Now P is equal to P1 is equal to P2. Here P is equal to rho GH. So P1 is equal to P2 is equal to rho GH. Okay, we have to find the okay students, we have completed the manometer. In the next session we will discuss about barometer and so on. Thanks for watching this video.